So, a very good morning to everybody who is joining us from India, and a good evening to the guys who are joining us from US, and welcome to this webinar on the topic of Hadoop for Java professionals. I hope all of you are able to hear me. That's great. Good morning, Amit, Sachin, Amrinder, Sai. So, very good morning and probably good evening to some of the guys who are joining us from US. So guys, this is the session about, wherein we'll be talking about the possibilities of, Java professionals in distributed world. And when we talk about distributed world, we are typically talking about Hadoop. So it's 8:01 a.m. sharp. I hope it is okay if we could just wait for a couple of more minutes, because I can already see that there are a lot of attendees who have already joined us and many more are pouring in. So I hope it is okay if we just wait for 1 minute or so, right? That's great. That's great. So by the time, let other people to join us. So first of all, thanks a lot for attending this webinar, for basically Hadoop for Java professionals. And a little bit about myself. My name is Vishal, and I am having around almost 10 years plus experience, overall industry experience, and since last I would say almost 4 years I'm working in big data domain. So when it comes to big data domain, I typically work in Hadoop background, so entire Hadoop framework and some non-Hadoop things as well, like Storm, a bit of Cassandra, and a bit of R and all. So it's a different ball game altogether. But yes, extensively I've worked in Hadoop area since last almost 4 years. When it comes to the domains and all, my primary experience goes towards the retail domain, a bit on telecom, and banking domain as well. So I think that's pretty much about me, and I do definitely see that there are some more people who have attended 1 or 2 batches which I have taken earlier. So I keep taking batches with Edureka quite regularly. And let me just get started with it. So I do see that yes, there are many more people who have joined us now. So guys who have joined just now within last 1 minute, I can see that there are almost some 30 or 35 more people who have joined in last 1 minute. So welcome to this session. And guys, it's about just a sec. Yeah. So the objectives of this session, why exactly we are here, for this entire session. It is all about, so the target audience for this entire session is going to be the people who are having Java background, who have good working knowledge of Java, but they are not really familiar with the distributed processing frameworks or distributed processing environment altogether. Whereas if you talk about it, as you will see within the presentation itself, within the discussion itself, that there is a huge demand for the Java professionals in the area of big data, or specifically when you talk about Hadoop, right? So before we jump into why exactly, what exactly is the demand about Java professionals in Hadoop area and all, it would be a good thing to spend some minutes to know what exactly is big data and what exactly is Hadoop. So some of you who might already be aware of Hadoop and all, probably some of this part might be a bit repeatable, but a lot more people who are completely new to Hadoop, this might act as a primer. This is not everything, but it is just a primer or just a glimpse of what exactly do we mean by big data and what exactly do we mean by Hadoop and how exactly Hadoop fits into big data problem solution itself, right? So we'll be talking about big data, Hadoop, why exactly Hadoop is required and all, and then there would be some interesting some of the interesting statistics which we have collected over Google Analytics and all. So some job trends about Hadoop, Java, and the combination of it. Then we'll be taking a very brief kind of crash course of Hadoop ecosystem. So when we talk about crash course, it's all about just touch and go kind of thing, and also the kind of ecosystem which we are presenting to you in this session, keeping that keeping in mind that entire duration of the session is going to be 1 hour. Of course, it is a much stripped down version. So some of the basic elements wherein Java is prominently used, we'll be talking about them, and then there would be a point about MapReduce programming in Java. So here there is an interesting thing which is going to happen. So today I'm going to show you one simple program in MapReduce, and by the way, it is not going to be a word count kind of a program, because this is one of the simplest ones which are always shown everywhere. So at this point of time, by the time we'll reach up to the point of MapReduce programming in Java, of course, we are not covering what exactly is MapReduce, what exactly is the paradigm and all. So when I would be explaining you the example, please do not focus it from the understanding or from the expectation that MapReduce is being explained. It is all about, I just want to showcase, I just want to show you that if you know the paradigm, then what exactly does it take to apply the paradigm in the using Java language. That is one that is the focus of MapReduce and paradigm. MapReduce programming and Java topic itself. Then so Java use within Hadoop ecosystem doesn't stop with MapReduce itself. It extends beyond. So over the period of time, there are a lot of wrappers which have been built on the top of MapReduce to ease the work of programming itself. But they have their own limitations. They have their advantages as well as disadvantages. But yes, when you hit the boundary, the way to extend their those wrappers altogether is Java, primarily Java. So there is something called Pig, there is something called Hive. You will hear about it when I'll be talking in when I'll be talking about them in Hadoop ecosystem. So of course Java has got its handle in Pig, Hive, as well as in something called HBase also. So HBase, I think I've not kept any slide for it, but I'll definitely talk about it. HBase is kind of a real-time handle of Hadoop. Okay, it's called the database of Hadoop also. But yes, when it comes to HBase, the primary, or I would say for all practical purposes, all of your interaction with HBase happens only and only through your Java client, Java interface and all. Okay, so this is more or less overall objectives of the session, and I know during the course of discussion there will be a lot of queries which will be in your which will be popping up in your minds. More are the queries, the better it is. It shows that, of course, the conversation which we are going to happen is definitely effective. So, however, we have a time frame as well, like 1 hour, probably some more time over on the top of it. But so if within this period of time, of course, answering almost some 300-400 queries is practically not possible. But for this, what we have done is there is a Twitter handle, as you can see within the within the slide itself, Edureka @edureka.in #ask Edureka. So you can post your queries we'll try to see if your queries are, I mean, there is a team which is already sitting within the webinar, and as and when you are typing the questions, you would be getting some of the answers. But still, the number of participants is overwhelming. So of course, answering all of the questions on the real time might not be possible for us. Just put your questions on this Twitter handle. A few experts are sitting and watching this this hook, and definitely they'll be able to reply on it. Okay, and at the same time on Facebook also, you can just type your post there. You will be getting the response, just in case if you do not get the response, naturally within this session itself, right? So are we good to go, guys? Right? Great. Great. So now, moving ahead. So guys, first of all, the first thing first, it's about what is big data. If you talk about it, and specifically those guys, who are core Java guys, not really from this domain and all, specifically, who are from web development area and all that stuff, it might be a bit new term. In the very simplistic way, big data, as the name suggests, it typically means lots of data. Okay, it is very simplistic version which I have told. If you see, and it's kind of a moving target. So in the bracket it is written terabytes or petabytes kind of thing. I'm not first going into that area. Some years back, if those people who have worked in the typical RDBMS background and all, you would definitely have heard that if your database file size, those guys from Oracle and all, like DBF file size is in several GBs, you are typically talking about a big data kind of an instance, or you're typically talking about a very large database instance and all. So this was the picture around some 3 or 4 years back. But nowadays, if you talk about a big data instance or a big data problem, the scale, we typically mean by the scale wherein we are talking in the terms of terabytes or petabytes. Why are we not talking in the terms of GBs and all anymore? Because the traditional systems themselves have caught up and have come up with some sort of I would say workarounds to deal with some GB level kind of data. But when it comes to the terabytes and petabytes kind of a scale, definitely this is not the ball game of the traditional systems. Right now, today in 2014, we are talking in terms of terabytes and petabytes. Probably 1 year down the line, when somebody else would be taking the session and some other group would be talking about it, probably the scale would be some petabytes plus, petabytes to exabytes and all that stuff, right? So this is typically, it means lots of data. Okay. So what exactly are the challenges which it brings? I mean, what exactly is so different? So big data has become almost kind of a buzzword nowadays. Is it only the volume? Is it only the volume which is creating the problem? No, it is not really the one. So the challenges which it brings along with it is, since of course you are having such a huge collection of the data, it becomes very, very difficult to basically collect all of the data and crunch all of the data using the traditional data processing applications on a single system, or even for that matter on the distributed, there are some sort of limited distributed capabilities which are available. It becomes quite difficult there. Also, it is you talk about various aspects of your data elements, like you talk about storage of the data, searching on the data, indexing of the data itself. You talk about the data transfer and analysis as well as visualization. So you talk about any of these aspects which typically fall in the area of analytics or BI and all, they all become difficult. Okay, it is one factor, of course, is volume. The second factor is all about the variety of the data. So when we typically talk about the data from the traditional systems, using those traditional RDBMS systems and all, wherein you capture the transactions, store it, and then probably use some of the history transactions for your analytics purpose and all, you're all the time you're talking about the structured data, the data which is typically there in the tables and all, right, in your database tables and all that stuff. But when you come to big data world, it is not really just the structured data. So what I mean by it, in order to explain a bit more on it, let me move to the next slide. Yes. Okay. So when we talk about it, it is all about if you see this particular slide, this reinforces the same point which I was telling in the last slide, wherein I was saying that the data volume is growing, but if you see, it is kind of exponential, right? So the second aspect which is very important is, it's not just the volume, it is the velocity of the data. When by velocity I mean the rate at which you are collecting the data. There are several examples at this point of time. Probably I'm not really in a position to share all of that, but I'm quite tempted to share one example. You typically talk about a jet airliner, right, which goes for a 30 minutes kind of a flight, right? All the data which gets generated using it, through its sensors itself, is almost 1 terabyte. It's almost 1 terabyte sensor data which is generated only for 30 minutes kind of flight. Now think about a flight which connects, let's say, Mumbai and Delhi in India. And then think about a flight which is connecting both the ends of an Atlantic, right? We are talking about a huge amount of data. And this is about one flight. Now think about all of the flights connecting all of the different parts of world within a single day. Isn't it a mind-boggling amount of data? I'm sure it is, right? And it is not just a mind-boggling amount of the data. It is about, within a day, how much data is present around you. Velocity. This is what I mean by velocity of the data. Right, guys? I hope it is, that velocity part is quite clear, especially to the guys who are completely new to this part, right? The third thing is the variety of the data. So when I talk about it, I was just talking in the previous slide, I was talking about the structured kind of a data, but when you come to the big data world, there is a third element, which is the variety of the data, that becomes very important. So just in the previous example, I talked about the sensor data. This is not the data which is coming straight out of your database table, right? It is kind of some sensor data which is generated as a binary stream coming from a kind of a device to you, and you have to analyze it, right? Or you talk about your images, you talk about the video files, you typically talk about those mainframe files which you might have to consume, right? Packed decimal files and all that stuff. So all of this data is of various, changing in its nature, and at the same time the treatment also changes. The way you are going to treat a text data versus the way you are going to treat the data which is in the form of an image, right? Essentially a binary file and all, of course the treatments are going to be completely different. So the challenges in front of you are basically these 3 points which I just talked about. One is volume. I don't think I have to explain more about it, right? Velocity, as I said, the rate at which you are capturing the data. It's not just the volume, it's the rate at which you are capturing, possibly or potentially crunching also, right? So that's the velocity part. And the third part is variety of the data. So as I just told about it, you might be getting some sort of structured data, many cases unstructured data. If you are lucky enough, then probably some sort of semi-structured kind of a data, let's say some XML files or some sort of JSON format kind of a data and all. If you are going to get this kind of data, yes. So your horizon is now quite broadened in this case. It is no more related to only structured kind of a data, right, guys? So this particular graph, right, which you are seeing, is actually showing you that data is increasing exponentially. Nothing new about it. From last 2 slides we have already talked about it. But the new thing which you are seeing is, if you see this graph, there are two partitions of it, or there are 2 aspects of it. The blue color line, right, that shows the growth pattern of your relational data. The data which is generated from your traditional systems and all, yes, it is also increasing, but not at that much alarming rate as your application data which is increasing. When we talk about the application data, it is typically meant by, the data which is generated by IT systems and all. So you go and you click on, let's say, somebody's pic on Facebook and say like, or some sort of comments and all. A lot of user generated content which is being generated via websites. This is one such example. The other example might be those web logs and all which are being generated, your server logs which are being generated. So if you talk about all of these sources of data, none of them fall in the category of your structured data itself, right? All of them are the examples of unstructured data. At the same time, all of them are the example of application data. Okay, guys, I hope that's quite clear, right? So this is, if you see, the data explosion or the data growth is actually driven by the unstructured data segment, not by the structured data segment altogether. Okay. So Jitendra says, I think an aeroplane generates 10 terabytes of data in half an hour. It is basically 1 terabyte of data. Sensor data, we are talking only about the sensor data. There are a lot of other devices and radar data and all. There are so many other data which get generated, but if you just focus only on the sensor kind of a data, this is a typical statistics which comes into picture. Okay, Jitendra? Sure. So by the way, I was able to answer his query because I just looked at it. There might be a lot of other queries which are pouring in, guys. So I'll try my best to answer, but I hope you understand that within 1 hour it's not really possible to answer all of them, right? Okay, so when it comes to the challenges and all, basically I have already discussed about the content which is shown in this slide. It's all about your increasing data volumes and your new data sources and types. Exactly, it is the same recapitulation. I mean, I spoke more in the previous slides, rather than coming to this slide. You can just treat it as kind of recapitulation of the same thing, right? On the left-hand side, you can see that your data volumes are, will keep on increasing, and on the right-hand side, you are seeing that your new data sources, which continuously are being added, your transactions, OLTP, OLAP kind of a data, social media or weblogs, or your emails and all, or machine device. So basically, a lot of so in telecom world, when I had a brief encounter there about of implementing big data solution there. So we typically get all of the noise data. When you talk about noise data, it's like a data which is being generated on all of those towers and all, right? So typically it is of no use for the voice quality purpose and all that stuff, but definitely it is of use of for our own internal analysis kind of thing. So there is a wide variety of data when you talk about it. Okay, moving ahead. So this was kind of up to now what we had looked at as big data. We have not yet talked about Hadoop, but I hope this was good enough, or at least good enough starting point for you to think that what exactly is the problem which we are talking about, what exactly is the scale of the problem which we are saying that we are going to solve, right? We're using Hadoop. So Hadoop is definitely not the ball game for sub GB or GB kind of GB scale kind of data. Okay, so 1 GB, 2 GB data and all. If just to process that, if you are planning to use Hadoop and other stuff, probably I don't really see it as a very good point. But yes, if you're talking about several GBs, like 100 GB plus kind of a data processing which you have to do, which typically nowadays most of the organizations are reaching, right? Most of the organizations are reaching up to that stage. So that's where the ball game, or I would say that's where the playground of Hadoop starts. So wherever your traditional systems end, Hadoop starts on the top of it, right? Now, before even coming to know what exactly is Hadoop, let's look at some of the Hadoop job trends. By the way, these are the job trends which are not from Edureka. They are, Google Analytics, some of the exports which we have taken, and we are just showing it to you. So it's about your job trend and all. If you can see that up to 2000, even 2010 start, there was a flat, this thing, almost zero traction, within industry. So when I started, adopting Hadoop, at that point of time, the only documentation which was available. Today, if you type Hadoop, you will get a lot of material. Okay, but at that point of time, it essentially the material which was available was just the Java docs kind of thing, and there was absolutely nothing. But yes, nevertheless, there were some niche companies which were specifically, let's say, either at the Facebook level, Google level, and all that stuff, or the companies somehow associated with them were using Hadoop. Not many. Even in fact, many people didn't even know what exactly is Hadoop and all. But over the period of time, from early 2010 onwards, we are seeing a industry spread adoption of Hadoop. So there were various other reasons. I mean, this is not really the right platform to go into those reasons, but for various reasons, even if the big organizations, or rather than big organizations, most of the common organizations like TCS, Satyam, Infosys, Wipro, and all, you talk about them, they even if they were aware, none of those organizations had the big data practices among them. But from 2010 onwards, it's an industry-wide kind of observation that most of the companies have started their big data practices. And when you talk about big data nowadays, at least I can see definitely for coming some more years, Hadoop is going to be synonymous of big data. Though big data is much more wider thing, as you can see that it is all about volume, variety, and velocity of data. So Hadoop is one way to tackle this much huge amount of information in such a small time. But the idea is Hadoop is right now kind of de facto standard. So from 2010 onwards, you can see it's kind of exponential kind of a growth which is happening, and primarily due to the reason that specifically companies in India and across the world are now waking up and then seeing that big companies like Google, Facebook, talk about Yahoo and all, they have successfully implemented and have taken their businesses to the next level. So people are now realizing it. Of course, this trend is growing up. Whereas you talk about the Java job trend and all, so this is kind of constant, because so Java also at some point of time must have, I mean, it has already seen that kind of exponential rise at one point of time, but right now it is kind of, more or less kind of a constant kind of a market, wherein that there is enough good demand and supply kind of a thing. So there is a good demand for Java professionals, at the same time there is a good supply for the Java professionals and all, right? So these are two distinct things. But what happens is, what is more interesting is, if you look at the next slide, just a sec, right? So now, when it comes to job trends of Hadoop and Java combination, you can see that Hadoop itself has started becoming quite popular in early 2010s, right? But the Hadoop and Java job trend has kind of almost picked up over 2011 mid, or even starting itself, I think. So 2011 mid onwards, there is a kind of quite unexpected kind of an upsurge in the in the demand for the skill set of Hadoop and Java combinations. There are reasons for it. There are specific reasons for it. Those are the things which I'm going to cover in the coming slides. Okay, wherein I'll be talking about, I mean, why exactly Java is the main reason, or why exactly this combination has become so lucrative right now. Okay, so as you can see that if you move towards it, only I'm talking about all those guys who are completely from from core Java guys, and all, who have spent all of their lives in doing Java programming and all. But now what? Now what next? So this exactly is the place which can take you to the next level of growth, or I would say, as people say, that career phase 1.0, career phase 2.0. So this is kind of that migration which we are talking about, okay, which can really help you. But of course, for that a good understanding of Hadoop concepts are required, along with the application of Java. So this is something which is important. Now I'll just take it to the next slide. So even before we go to Hadoop and all, it's all about the kind of job openings which you will see typically in your Hadoop world. So typically, if you talk about it, as you can see here, it is Hadoop developer. You talk about Hadoop developer, Hadoop engineers, big data engineer. They are all kind of same job profiles. These three, even though the names are different, as of today, guys, as of today, they are nearly the same kind of profiles, because nowadays, which are the starting days, I would say there is no clear-cut distinction between the administrators versus developers. So typically, I mean, I have been the part of 3 organizations wherein we have started Hadoop practices from scratch. And at that point of time, let me tell, it is all about you have to set up the cluster and all that stuff and do the programming as well. But however, very soon companies are now realizing, and they are going to have their, most of the companies have started their admin separately, their development separately. So Hadoop engineers typically would go towards that admin side of it. Hadoop developers, right? Hadoop developers and big data engineers and all will typically go towards a developer kind of a community. But big data engineer is a bit broader term rather than Hadoop engineer, though for now and at least in coming some years, I do see both of them as kind of interchangeable thing. Then there are demands for Hadoop architects. So I am in this market from quite long, and I do see that there are so many Java architects who just many times they claim to be a Hadoop architect, but apart from Java knowledge, it requires a lot more when it comes to Hadoop. So it essentially needs some sort of admin knowledge. It needs the knowledge of Hadoop intrinsics, how exactly it works. So it's all about planning your entire clusters, planning your data growth patterns, planning exactly about you're setting up your ACLs and all that stuff. So basically, Hadoop architects, it's one of the, I would say they are the rarest. It is the most difficult hiring decision, or this is the most difficult hiring position for almost every company nowadays. Then there are other segment of jobs which typically goes towards the data scientists and data analysts kind of, this is another role wherein you talk about data scientists and data analysts and all. So data scientists, again, there have been a lot of data analysts in past. I mean, typically people who are from SAS background, typically people who are from R background and all. It is very easy for them to make a transition towards it. But again, in order, as I have told, data scientist is not really kind of a job position. It's kind of a role which you play. So typically these guys will be having their, let's say, designations as probably sort of data analyst or senior data analyst or something like that, but the role would be of data scientist. So typically these guys are the ones who are good with hacking skills and all that stuff. So it might sound a bit flashy, but it is all about, you should understand your data very well. You should have some sort of good domain knowledge. At the same time, Java comes handy there because you will be using Hadoop and all, and plus many more. So that plus many more things typically involve good knowledge of Mahout, good knowledge of R, good knowledge of some sort of other machine learning mechanisms altogether, some sort of other databases like MongoDB, Cassandra, etc. So this entire combination typically goes towards the data science kind of a territory. But yes, having said that, Hadoop opens all of these, Hadoop is the integral part of any of these job profiles, and it opens up all of these possibilities to you. That was the overall purpose of the slide. Okay. Now, so Hadoop for Java professionals, again, Hadoop is red hot right now. You talk about it, I mean, you don't probably, I would say, kind of, you don't really need much of the proof. You can just go to any of the websites or those job websites and all. You just type about it, you'll come to know what exactly are the kind of openings or what exactly are the companies for which these openings are, right? So it is it is red hot because it allows you to do the distributed processing on those large data sets across the clusters of commodity computers. Okay, so typically it's all about, you don't spend the money on large machines and clusters and all about it. It is all about get some sort of commodity hardware or the cheaper hardware and then create the clusters on the top of it and go for the scale out kind of an model. So of course it goes for the reduction, where basically companies get huge cost reduction in terms of the data crunching which they have to do. It has almost become a de facto standard. I think I have already talked about it. And nevertheless, it is much cheaper as compared to your traditional tools. So you typically talk about IBM mainframe and Oracle databases and all, licensing cost plus AMC cost and all. It costs a bomb to companies. And I am personally aware of 3 very, very big organizations, okay, really big organizations, which were scared to, or rather than scared, I would say, they were trying to limit their analytics operations just because they had to pay a lot to SAS. They had to pay a lot to Oracle in order to do some sort of X amount of processing. That's where they have started moving towards, from mainframes, or when it comes to mainframe, they need additional MIPS. Additional MIPS means additional money, right? So it's all about, so these are some of the practical limitations altogether. So Hadoop definitely is much cheaper because licensing costs and all other things are involved only if you go for support. But if you do not go for support and all, most of these things are free. That is first thing. It is open source. So if you have a good team of professionals, you are allowed to, you can just change the source code accordingly. So I am aware of a retail giant in US. There I've been the part of that team wherein we have taken Hadoop and we have changed some of its properties according to our own requirement. Okay, so that's kind of parallel distribution of Hadoop which companies are running nowadays, and using the same thing, like talk about IBM, talk about Oracle. They know that this is a change which has triggered a massive paradigm shift within the industry. So they themselves are coming up with their own Hadoop distributions. Oracle is coming up with its own Hadoop connectors and all that stuff. So yes, there is a big change which is happening across the industry right now. Okay, so that is one of the reasons why it has become kind of red hot technology. Now coming to the point wherein so Hadoop is definitely a natural career progressions for those Java professionals because entire Hadoop is written in Java. Entire Hadoop source code is nothing but core Java, guys. Okay. The combination of your Hadoop and Java skills, as you can just see that it is one of the most on-demand kind of skills which are there in the market. And the Java skills in Hadoop don't really limit you to the understanding of Hadoop. So when I say Hadoop, it means it is completely written in Java. Very good. You know the framework, but at the same time, it allows you to do MapReduce programming using Java. Of course, you need to know MapReduce paradigm, but if you are aware of it, using Java, you can do the MapReduce programming. Apart from this, there are some wrappers which are built on the top of it. Even you have to extend the wrappers. You can, so like Pig and Hive, there is something called UDF, basically user-defined functions and all. If you have to apply them or kind of create your own custom storages, loaders, etc., you can. As of now, the support is only for Java.
okay, and HBase, right? I think these three things I talked about it at the very start itself. So HBase is primarily, Java client driven, okay. So most of the interactions with HBase, they don't really happen through the shells, just like you have SQL prompt and all. There is an HBase prompt also, but typically people don't do that interaction via, I would say, the prompts, or probably via some scripts, as you see .sql kind of thing. No, they don't happen that way. They typically happen with your Java programs and all. So Java is an important tool even to interact with your Hadoop ecosystem itself. Okay. Now that I have talked about Hadoop ecosystem, the time is ripe to talk about Hadoop. What exactly is Hadoop, Hadoop for big data and all that stuff. So guys, this, in fact, you would have noticed this is for the first time when I'm talking about Hadoop here. So when it comes to Hadoop, it is, I have talked to many people. Many of them say Hadoop is a tool. Some people say Hadoop is a database. Some people say Hadoop is kind of operating system. No, guys, Hadoop is a framework. Okay, it's a framework which allows you to do basically the same thing which I just talked about, that it allows you to do the distributed processing of large or humongous data sets by distributing them in the cluster of commodity hardware or commodity computers, okay, using the simple programming model. That simple programming model is called MapReduce model, okay, and it is open source. It is completely open source, which provides you scale out as well as scale in. Scaling should not happen, by the way, but anyway, technically scale out as well as scale in storage, and of course the distributed processing using MapReduce itself. When I talk about it as a framework, so what exactly is a framework? Like struts, like you talk about JSF, you talk about Play, you talk about Ruby on Rails, all of these are the frameworks. And what do? They provide you a lot of utilities, inbuilt utilities and all, which help you to do your work. In that case, kind of web development, kind of enterprise development, all that stuff. The same is true for Hadoop. So Hadoop is a collection of a lot of tools all together, okay, which will allow you to do your respective works. You will get a glimpse of it in the coming slide. So when you talk about Hadoop, at the core of it, it is having two components. One is HDFS and another one is MapReduce. So HDFS, at the end of the day, HDFS is the storage component of it. This is where you will store all of your data within Hadoop, okay? And MapReduce is the processing side of the story of it. This is where you will process all of your data within Hadoop, okay? So, or I would say you will use MapReduce paradigm to process all of your data in Hadoop. So when it comes to HDFS, it is kind of so I just talked about commodity hardware and all, right? So in Hadoop, since we are using commodity hardware, the failure, right, guys, I repeat, the failure is something which is not unexpected. Failure is always expected, because you are not applying any kind of SAN configuration, you are not talking about any rack kind of, those software, NLBS kind of software and all, you are not applying any of them. So the kind of, failures and all, they are quite expected. So Hadoop or HDFS is highly fault tolerant in itself. It is natively redundant. So basically the first point and the last point go hand in hand. So when I talk about redundant, it is like it just keeps the redundant copies of the data. There might be a separate debate which will say that redundant copies, it means are you going to keep multiple copies? I will say yes, by default there are 3 copies. You can change the replication factor. It would go in a different debate that you are increasing your storage costs and all. So probably not in this class. If you will attend some of Hadoop classes, then you will come to know basically the cost which is involved in the storage is much lesser as compared to the cost which you will put in buying the high-end processors and other software and all this thing. Okay, so by being natively redundant, it is typically highly fault tolerant. That is from the storage side itself, and also it it is typically suitable. I mean, typically HDFS is called suitable for small number of large files versus large number of small files. Okay, so typically, I mean, it does not stop you in putting some KB files in HDFS and all, but some KB files and all are typically not suggested, kind of thing. Okay, so there are different reasons. Not really, this is not really the right time to talk about it, but this is kind of glimpse of HDFS. But yes, it is the storage side of story. Okay, and the main points here is the main points here are that it is all about, it is fault tolerant because it is natively redundant. These are the key points to take at this point of time, I would say. MapReduce. When it comes to MapReduce, it's all about, it's a paradigm altogether, which basically works in the form of key value pair. So it is very difficult to explain it, let's say within 10 minutes or even in 1 hour. Typically when I take the classes, so there is a almost, I mean, there is a scheduled duration of 3 hours wherein we just cover about the paradigm itself. Okay, so but at the same time, at the heart of it, all of the MapReduce programming happens on the assumption that you would be working in the form of key value pairs. So if you are able to express your problem in the form of key value pairs, you are able to process, or you are definitely able to provide a solution using MapReduce. That is for sure. Okay. Now the idea is the key value pair only thing which helps you to solve the problem? No. This is one component of it. The other component of it is MapReduce allows to process your data in the distributed fashion. It basically, it splits the task, or it splits the calculation into multiple small tasks which would be running on different data set, like different parts of your data which might be stored in different machines altogether, and gives you the result by combining the results from all of them. Okay, so now when I talk about it, it might seem a bit complicated, but at the end of the day, you as the user of Hadoop would just be writing only the mapper and the reducer. All of the other things, right? Distribution of your code, distribution of the data, processing it on different machines, monitoring the input, in case of failure, relaunching it, or telling you whether the failure has occurred or not, and then once all of the process is over, then giving the result back to you. All of that is handled by Hadoop. So you as a programmer have to focus only on the business logic, not on the logistics, right? So this is just one part of it. These are basically two core components. You talk about your Hadoop cluster, okay? So Prashant, I hope you got the answer, right? Hadoop stores databases or files. Basically, you can store any kind of data. You talk about files. You talk about some database exports. You talk about video files, audio files, image files, and all. It is just a file system. Dump it. Got it right, Prashant? So I'm talking about Prashant Jaiswal here. Okay. So great. Now let me just go to the next one. I just looked at his question by chance. Okay. Now this is Hadoop ecosystem. This is about Hadoop ecosystem components. When it comes to Hadoop ecosystem components, this is a stripped down version of Hadoop ecosystem components. These are the bare minimum, or rather than I would say, HDFS and the MapReduce framework is the only two things which are the core. Remaining things you can even take out, but your Hadoop cluster cannot survive, or your Hadoop cluster cannot work if your HDFS component is not working or you do not have MapReduce framework. That's for sure. Okay. Now, if you see about it, it is HDFS, which is the storage side, MapReduce framework, which is the typical computation model, okay, in order to exploit the data which is stored in HDFS. Now, there is a big developer community. Over the period of time, people became aware of Hadoop, what exactly it is, its power and all. And there are many people. You guys are from Java background, guys. All of you are from Java background, I am assuming so. That's why you are attending this session. But believe me, there is a much bigger number of those guys who are not from Java background. And yet, they want to take the power of Hadoop. They want to leverage the power of Hadoop. For those people, there are various wrappers which were built on the top of Hadoop. But two of the most prominent of them are Pig and Hive. So Hive is typically kind of, it provides you kind of SQL language. Okay, it is called Hive QL. So just like you can say select something from some other table where you apply some sort of filter criteria, you can do the very same thing in Hive. So people just write their SQL queries, and Hive converts those SQL queries to MapReduce jobs by itself and then exploits the data. Similarly, the same is true with Pig. So instead of providing some sort of SQL statements, it's kind of a data flow language wherein people provide some sort of data flow in the form of something called Pig Latin. Okay, it is a kind of abstraction. So typically, let's say a MapReduce program of 200 lines can be converted into a Pig program of, let's say, some 10 or 20 lines, not more than 20 lines and all. So specifically, but again, these are the tools which are specifically for the people who are not aware of Java, who cannot really write MapReduce programs, but they understand the paradigm. But they cannot write the Java programs and all. So typically for them, it is basically Pig and Hive which are there, which internally will launch the MapReduce for them. So it's kind of, you write your SQL queries. At the end of the day, there is a program, there is a plan which gets created, and then you fire your query and you get the result, right? But you typically don't execute the program. This is your SQL parser, which will be doing that kind of syntax checking and then creating a plan and then executing and getting the results for you. Similarly, these are the components which do the nearly same work for you. HBase, you can see that it is within MapReduce framework and right on the top of HDFS. So I would not cover much about it right now. Just to tell, HBase is the only component which can get the data from HDFS without the involvement of MapReduce in it. That's why it is much faster also. I would keep my statement short and limited up to this point, okay? Because otherwise it would be a bit of digression. But yes, having said that, the reason of showing HBase here is even in the HBase also you have the Java hooks only. Okay, so talk about Hive, talk about Pig. If you have to extend it, if you need more power, you do not have any other way than Java to go for it. Okay, now just a second, guys. Okay, so what exactly is a MapReduce? I had just explained it. It's all about, it works in the form of a record-oriented key value kind of a processing. It distributes your task across multiple nodes, or you can call multiple nodes right now. You can assume multiple nodes as multiple machines themselves. Okay, typically it has two phases. One is the mapper phase, another is the reducer phase. Okay, in the mapper phase and all, you just prepare some sort of key value pairs, and on the reducer side, you take all of the records for a given key together and perform the business logic. So most of your business logic is written typically in the reducer side, and most of your key value preparation logic goes towards the mapper side. Okay, so this is a typical I would say model, but this is, I would say, 20,000 feet view, not even 10,000. This is 20,000 feet view about it, because how exactly, Hadoop or MapReduce converts your record into a key value pair, how exactly do they flow within the network, what happens behind the scenes, it's all in Java. Okay, so it would be quite interesting when you'll attend those classes. At that point of time, you will come to know that, okay, for you as a programmer, probably mapper and reducer is the only thing, but what exactly Hadoop does in between, that is again happening in Java. So it would be quite interesting for you to know. At the end of the day, if you want me to summarize that what exactly, let's say, is MapReduce in terms of some simple statements, so it is all about, let's say I have to do a grep. Okay, I have to do a grep on a particular file, then this is a typical command. If you say cat whatever your file is, and then you grep for a given, let's say right now I'm talking about .html, but you grep for, let's say, Vishal. So you will get all of the records which are having Vishal in it. You do a sort, then you perform a unique and take the output and store it in some file, right? In this case, we are storing it into /my/output file, right? This is typically MapReduce process which is happening. Typically mapping, sort and shuffle, and then there is something called reducer phase. Okay, so if you talk about it, if my objective was to get only the unique records, right, for a given kind of let's say key. Here the key is .html, tomorrow it might be something else which I have to search. Probably the MapReduce program would be written in such way. Mapper, then shuffle and sort. This is inbuilt in Hadoop. You do not have to worry about it. And the reduce phase, wherein you will be performing the unique logic itself. Okay. Moving to the next slide. So, talking about hands-on. So the time is ripe. Let's talk about hands-on part itself. So okay, while I was just seeing it, Nitin had an interesting question wherein he said, so Nitin Munjal, can Hadoop be used to process streaming data? Typically, you will use Hadoop to process streaming data only. Okay, so you would be accessing the data. Your mappers and reducers would be accessing the data using streaming. And there's a separate thing in itself called Hadoop streaming. Okay, Nitin, you would hear more about it when you'll be going, into the details of MapReduce, probably in the course itself. Okay, Nitin, I hope I have answered it. So Srinivas says, shuffle and sort, does it happen in the map phase or the reducer phase? It happens between the mapper and the reducer phase. Okay, Srinivas. Now I would not be taking any more questions. Let me just quickly go towards the hands-on part of it. So guys, when I talk about hands-on, it's not like I'm going to write the code for you right now, or probably I'm going to do a code walkthrough for you, because at this point of time, many of you are not even aware of MapReduce concept. What exactly mapper does, what exactly reducer does, how exactly it creates the key value pairs, how exactly the shuffle sort happens in between, what exactly is a combiner and all. I'm not going into those details. So please do not worry about it. It's all about, so when you will be looking at the code, just think that it's kind of a, so the idea would be that it's a core Java code which you are looking at. Whatever you might be having some doubts, what would happen for the data which I'm emitting and all, whatever I'm saying collected .emit or something. So where exactly this data is going and all that stuff. If the whole understanding requires the comprehensive, I would say, class for MapReduce itself that calls for entire class. Right now the idea is whatever you see that does not make sense, I mean how exactly it is happening apart from code, for now, for the sake of simplicity, you can assume that MapReduce along with Hadoop framework is taking care of that part. How? For that, anyway, we have to go into the details. Okay. So this cut is straight from one of our project discussions which we typically do in our classes. Okay. So this is kind of there is a website called Reddit. Okay. So typically people put a lot of material there. There is a lot of user generated content. So some people would post something on that website, and then there will be people who would be reviewing it, who will be putting their comments. So some of the comments may be positive, some of the comments may be negative and all that stuff, right? So the example which we are having here is we are having a typical XML file which we are seeing, and so everything starts with documents, right? And within that document, so this is the kind of a root tag of your XML file, and within this, the highlighted part, as you can see, there is a hash tag, there is a URL tag, category tag, user count. So they typically tell what exactly is the hash code for the given URL. Okay, what exactly is the category. So this particular URL falls in which all categories. So references, education, early childhood, so and so forth. So these would be the different categories in which this particular URL would be falling in. And then if you see on the on the bottom part of your screen, this is about reviews. So there will be multiple user generated reviews, some positive reviews, some negative reviews, and the beauty about it is these reviews could be 1, these reviews could be 1,000 or whatever number, right? So at the best, if you have to look at it, it's kind of a semi-structured data. It's kind of XML processing of the data. So guys, I'm not going into much details. I would be covering the example which will be having only and only one mapper. It will be having only and only one mapper in it, and we would be just running this job. What this job would be doing is, what this job should do is to do something like which you are seeing now on your screen. Okay, so basically, so Kiran says yes. The website name is Reddit. Let me just type it. Reddit. Okay, Kiran. Others? Sure. Now, coming back, so let's say the kind of output, for some reason, we need it in this way. I need to extract the category information. I need to extract the hash the hash code of the URL itself, then the number of positive reviews, negative reviews, and the total count. So if you see, you will get that category, you will get the hash code, you will get the URL, you will get the total count directly from the XML record, right? Directly from the XML record, you will get all of this: URL, category, count, hash code, URL. But getting positive counts, negative counts, and all, right? That is something which has to be done. This has to be done using MapReduce itself, or using the mapper itself. So we have applied, for the sake of simplicity, we have applied a very, very oversimplistic kind of a model to do it, but you might apply your own specific logics. So I'm going into the machine right now, and I'm opening kind of, so I have a project. You can see it's a typical Java project, review Hadoop, okay? And it has got, I definitely have to set the class path accordingly. I have to include Hadoop jars in the class path and all. Of course, that goes without saying, but without wasting much of the time, I'll immediately go towards, see, right now the class which you are seeing, this is import review.java. This is a typical mapper, okay? So there is a separate discussion which says why you need only mapper, why not reducer and all that stuff in order to understand. Anyway, as I've said, MapReduce basic, that data point is not there. So right now, please do not focus on it from the perspective of what is happening on the MapReduce. Just focus, see this is a typical Java program. I'm just creating a package. It is a simple class in the package. Most of the Hadoop specific classes like file input format, file output format. So these are the typical input format, output format which you have to specify. Which one you have to specify and all, of course, we'll go into the MapReduce discussion. But if you see your typical programs, you're just creating any class, just like all of you core Java guys. I think this is the place where you will be interested in, right? We're not doing anything new. We're just creating a class called import review. Within this, there's another class which we have created. It's all about in the class which, if you talk about it, it just extends the MapReduce base, class, and it implements the mapper interface. Okay, mapper interface. Since it implements the mapper interface, it needs to provide the implementation for the method called map. Okay, I'm not going into this, kind of signatures and all of these methods because doesn't make sense at this point of time. It is about, so we are, let's say you can see that XML parser XP, so we are creating an instance out of it. And then if you talk about XML parser, if you, let's say, press F3, you will go to XML parser itself. It has got some utility methods themselves. Okay, it's simple class. It has got some utility methods, XML parser itself, which is creating. So at the end of the day, we are using the SAX parser. Okay, and what we are doing is we are basically, you talk about user count, you talk about category. So if you provide category based on the get category method, so for the let's say given entire record itself, it will find out all of the records which fall under category tag itself, right? Similarly, get URL, get hash, and also there are various utility methods in it. Coming back here, so at the end of the day, see this is like, you can just some of the highlight points here. So you definitely need a key and a value, and you would be emitting a key and a value altogether. Here the value would be all of the things which would be falling under document tag, and we are in the program, it is as simple as using something called XML input format. So Hadoop provides these some of the utility classes to you, wherein if you are using XML file, you just need to specify that, hey, I want to use XML input format. You just have to tell what is your start tag key, what is your end tag key. So we are saying everything which is there between document and slash document, treat it as one record, treat it as one value itself. Okay, so when you talk about a value here, right, this value, this gets all of the data between a document and slash document, and then first you create, right, xp is equal to XML, new XML parser value.toString. So you first create an XML object out of it, and then basically XML parser object out of it, and then you just call the methods get category, get reviews here, and then once you get the reviews, then you are iterating through the reviews, and you can see there are two counters, positive equal to 0, negative equal to 0, which we have set to 0 initially, and then we are passing through the reviews. And right now it's a very simple logic. So bad words is another class which we have created. If you go towards it, you will see that it's a static collection, right? Some sort of words, and we are seeing whatever string we are passing, whether it falls in this collection or not. Okay, if this falls in the collection, then we return it as true, otherwise we return it as a false. But tomorrow, when you are applying your own logic, you might be integrating some sort of dictionary, some sort of text matching, some sort of, all of those context matching kind of a thing in it in order to determine whether a review is positive or not, right? So if it is true, then we increase the negative counter by 1, but otherwise we increase the positive counter by 1. So this way we come to know, okay, what exactly are the negative reviews or the positive reviews for a given document, right? And once we have identified this, then at the end of the day, since we are having categories, right? If you remember, in the original document, we had all the categories as a single record, but this time we are emitting them as one by one new records altogether. So we are iterating through the categories, and this is a typical way of emitting the records. So you are first creating a string, wordutil.cleanwords.echat. So when I say wordutil.cleanwords, it is a class which is basically just cleaning up some of the spaces and all that stuff. So, it's just doing a trim operation and things like that. Then I'm applying a delimiter. Delimiter is defined here as comma. Okay, this is comma. So basically your category, comma, xp.getHash. If you talk about xp.getHash, it is, let me just show you. See this? I look for the element by the tag name hash, and whatever comes, I just return it here, right? So let me go back. So you'll apply the hash, then the URL, then the positive and negative counters which you have already added, and then the overall user count, right? So similarly, if you talk about user count, you go there, you'll be looking for the tag called user count, and then you'll be returning the value here itself, right? You typically put this and then say output.collect. This is the moment you say output.collect, that's it. So somebody was asking whether, streaming data and all that stuff, right? So Sumit, I hope you have seen badwords.java, right? So by the way, coming back, so you are saying output.collect. Now from this point onwards, Hadoop framework plays its own role, wherein it writes the output into the designated output file. You do not have to specify which file you are writing into, okay, in the program. That will go from the command line. And then this is a class, but then again you need a main method, right? Which is, this is where we are setting, so you have to create a job conf object. Typically this is the object which is used to submit your job within the cluster, okay? Here you set all of your, basically configuration settings, wherein you are saying configuration.setting XML input format. You are specifying your start tag key, end tag key. You are specifying your job name. So what happens is when you submit your job, it gets executed in the cluster, and when you execute it, you can identify it by this job name. So it has to be a proper one. Number of reducer tasks are set to 0 because it's a mapper only job. We'll go into a discussion probably in the actual classes when you have to set it to what number and all that stuff. But for now it is 0. Then your mapper class output key class, output value class, and all that stuff you will be setting up in this. So basically at the very high level you will be providing all of the configuration settings. Then you can see here, this is something which you can focus. File input format dot set input paths. You are taking the first argument as the input path, you are taking the second argument as the output path. This is important because when I will be running it, you will be able to correlate. And then when I say job client dot run job, when I pass this configuration, the job is submitted to the cluster. I hope that is quite clear, right? I mean, at the very high level, right? So then you just simply you just create a jar file out of it. We are already over the time, so I'm not going into the steps of creating the jar, and because it will take some time. So rather than that, I had already created the jar out of it, and I'm now going to run the program. So what I have done is I had created this jar, sample project.jar, which is there in /home/cloudera. Okay, and then the first argument. Okay, and after that I have to first specify which class is my main class. So com.edureka.review.import review, that is my main class. Project input is my input. You remember the first argument is your input, the second argument is your output. This is where I say this is where I want to create my output. Okay, but before I proceed, I need to show you the input, right? So typically, just a sec guys, if you have to say Hadoop fs-cat, this is the command through which you see your data. The data is quite big. It will take some time to execute. So in that time I will be discussing a bit about PEG, and we'll be ending the session, and by the time we'll be completing it, I think the job would run, because the data which I have taken is not small. Okay, so I'm taking the first 40 lines. Okay, so you can see that it's an XML data, right? See this? This is a typical XML data which I'm going to process. So now I'm going to fire my command, guys. Okay. It would produce the output in /temp//xml out, and the output should be something like it. Okay. So this is typically a way of firing your command. You're firing your MapReduce job. So you say Hadoop jar, your jar, whatever you have specified, specify your main class, and then specify if there are any arguments to it. Okay, and then you'll be running it. In the production systems and all, typically you'll be firing these jobs via some sort of shell script and all, wherein a bit of some of the meta programming and wrapper level programming will come, wherein we'll be passing, let's say, input paths and output paths, probably by reading some sort of configuration file and then passing it all. So that's a different thing. But I hope you got the idea about how exactly you run the jobs. So this job is gonna take some time. This job is gonna take some time because the data is almost I think 2000 MB kind of a data. Okay, which I'm processing on the same machine. So let it to run. Let it to run. In the meantime, let me to return back here. Okay. Now, so again, for this there is no hands-on. This is kind of just to show you that how simple it is. So there is something called Apache Pig UDF. So first of all, when it comes to Pig, right? Pig is actually your data flow language. It's a data flow language wherein you specify your execution of data in the form of data flow. Okay, and Hadoop, or I would say the Pig parser, converts it in the form of Hadoop MapReduce jobs. Okay, these things are quite good till the time you are concerned only for a pure data flow. Means kind of SQL kind of operation wherein you are loading some file, you are selecting some specific fields, you are doing some basic transformations of the fields, and then let's say storing the data. Okay, so these are typical SQL kind of operations. You are good till that point of time. But there are some places wherein you might need to apply some of your custom logic, right? Let's say, so one of the not disadvantages, ideological differences of pig is it does not provide you any control structures. Okay, by control structures I mean if else, for loop, while loop, etc. So none of these control structures are there in pig. But when you are writing a program, you might be needing some of them, right? You might be needing some of them, or per record you might be doing some sort of remote database lookup, right? Some of the things might happen. So at that point of time, you might have to apply something called user-defined functions. The moment you combine pig with user-defined functions, it becomes one of the most powerful languages ever seen in big data world. Okay, so this is a kind of skeleton. I'm not even going through the code, guys, this time. This is kind of is of age is kind of a simple class. It just returns a boolean, true or false, based on some conditions. You can actually see this, right? You are simply extending filter func. Filter func is an extended class, abstract class, which you have to extend it, and you have to always implement a method called exact. If you apply the exact method, and then all of your business logic goes there. That's all. Just have a look, because it doesn't make a sense for me to go through the code right now. But so why have I put the code? Just to tell you that at the end of the day, isn't it any of the simple core Java programs which you have already worked on? I'm sure they are, right? All the times you would have worked with some class hierarchies, some sort of interfaces, all that stuff, right? Polymorphism and all. In fact, very less amount of polymorphism and other stuff is used here. But yes, up to some extent you can. In fact, nowadays new frameworks also are coming on the top of it. Okay, so guys, making some sense, right? So it is all about, even if you have to create some sort of UDF, some sort of custom processing which you have to do, you can do them using UDFs in pig. Again, Java will come handy for that part. So this is kind of straightforward thing. So how to call a UDF? Let's say you have created a Java class, but how to integrate it? It's all about, you create your UDF or your class, export it as a jar. In the pig script, just say register. Wherever your jar is there, you have to specify that path, and then simply if you have to execute it, you can just execute it by this. Is of age, sorry, just a sec. If you say is of age, basically it was your class. If you go back, see this, is of age is your class. You simply executed that class here. That's all. Okay. And the figure which is there on the right hand side, basically it tells, using pig you can express your data flows, and typically your execution environment, it goes in the local execution environment or the distributed one. So it could be local or a distributed execution also. The third part, it shows that when you submit the pig script, your pig Latin compiler basically converts them into the form of MapReduce jobs. This is what I told at the starting, right? That pig and all, basically your data flows will be converted to a sequence of MapReduce jobs themselves. And if there are any UTFs, that linking happens at the execution of the MapReduce jobs themselves. And when that step 5th happens, when you are creating your output, at that point of time, the dynamic linking of your UDS with the MapReduce job happens by itself, through pig. Okay, guys, quite clear, right? And I think by this, probably the session would end here, but okay, still the job is running. So let us just wait for a couple of more minutes before the job is over. By that time, I would be quite happy to see some questions, try to respond some of them. Okay. So Prashant had a question wherein Prashant says Linux admin can be a Hadoop admin. I don't have knowledge of any languages. Very good. So Prashant, definitely Linux admins, so just like I said, Java professionals are the natural, I would say, fit for being the Hadoop developers. They are definitely. Similarly, Linux admins are definitely a natural fit for being Hadoop admins. I would not give you the false hope by saying Hadoop developers. I'm not going to give you that false hope. So I would say, because as you have just seen, right, I just typed Hadoop fs-cat, right? So what exactly? It's essentially a cat command, right? So that is one thing. Now, just now the code got over. Let me just show you. There are some more inputs which are coming in. Hadoop fs-cat, this head anyway. See this category, URL, sorry, URL hash code, URL, positive count, negative count, and then overall count itself. Right. So this was all about executing a MapReduce job. I'm sure from MapReduce perspective, see this, my objective itself was not to explain the code from MapReduce perspective, because this is not the logical point, right? But yes, the idea was, even if you have to execute it tomorrow, assume that you have got the understanding of MapReduce. All you have to do is write simple old core Java programs. Nothing else is required. That was the whole perspective. Okay, so that is one. Then there are some people who are saying, can the examples be shared? So guys, all of this entire thing would be uploaded in Edureka blogs within 2 hours of this session completion. Okay, so it would be available, right? So that is one point. Another point is how Hadoop handles the unstructured data like images, videos, etc. So Girish, just like you have seen XML input format, there are some things like sequence file input format, binary input format, database input format and all, which basically take care of these kind of specific input formats. On the top of it, you can write your own specific custom input formats also, since it is completely Java based thing. Okay, it allows you to specify your own input formats and you can deal with this data. Okay, Girish, I hope I have answered. So guys, I'm not taking all of the questions. I'm just trying to take some of the questions which are quite common. So I'm just taking some of them, right? So Zookeeper as of now is being used HBase by HBase internally. You do not use Zookeeper explicitly by itself. Okay. How to get Facebook or LinkedIn kind of data into HDFS? So typically, in fact, in our course, there is an example wherein we are bringing Twitter data to HDFS and all. So there is something called Flume, which we typically use for it. Sachin? Okay. So guys, you are having many questions. So I would say, I would request, as I have told, that if you have more queries, right, please do post them at @edureka.in, hash ask Edureka. You will get more, specific answers for it. If I have seen some of the questions like, what is the good starting point for us to get started in Hadoop? So guys, all I would say is, if you are from Java background, as I can see that many of you are, then probably you can go for the course of, Hadoop for Java professionals. But if in case you are from Java background but are not in touch from quite a long time, then typically you can go for the course on big data in Hadoop also. Okay. Because there we just take care of people who are not from Java background as well, right? So that's the kind of response which I would say at this point of time. Okay, guys. So I know this is the kind of a very common query. That's why I'm answering all of, some of them, right? So I might not be remembering who has asked this question, but I remember the question. So guys, I hope you found it of some value. It increased some of, at least a bit of delta in your knowledge. But if it has, and if it has put some questions in your mind, then it is the success of this session. Okay, sure. Okay, so more such questions, please do post in our Twitter handle. You'll definitely get the answer. Thanks, Girish. Thanks, others. Sure. I think the overall training is of 30 hours. Okay, Obula? I think 30 hours training overall. Sure. Thank you guys. Now logging off, and thanks a lot again for attending it. I'm sure many of you who would be, uh, work up quite late night in US just for this session. Okay guys, now logging off. Thanks again.